All right, on for part 2 here. So what we've got over here is a picture that's missing an x plus 4. Basically, we're just trying to figure out what is the area of that red border, frame, etc. So what we need to do is a subtraction part. But first I got to figure out what is in my red. So I'm going to do x plus 4 times x plus 4 first. And when we do that, we'll get x squared plus 8x plus 16. Then on the inside, I've got x minus 4 times x minus 4. And what we'll see there is x squared minus 8x plus 16. So if I want to figure out what just this spot is, I'm going to take my x squared plus 8x plus 16. Again, that was the entire thing. And then I'm going to subtract what was on the inside. So this ends up being a subtraction problem. Just like up above in the previous subtraction problem, I'm going to change all of my signs x squared became negative x squared, negative 8x became positive 8x, and 16 became negative 16. Now I'm just going to combine like terms, so x squared minus x squared, that just goes away. 8x plus 8x, that gives us 16x. And then 16 minus 16 is 0. We're left with just a 16x. Number 10, factor out the GCF and write as a factored polynomial. So again, I'm going to look at two pieces here. I'm going to look at I'm first looking at numbers and then at variables. So from a number, I have 3, -9, and 6. Greatest common factor, I always look at the smallest number and does 3 go into -9 and to 6, and sure enough it does. So I'm going to factor 3 out. How about variables? I've got x to the 4th, x to the 3rd, and x to the 2nd. I have x's present in all 3 terms. I'm going to factor out as many as I can, which is the smallest degree. So I'm going to take out an x to the 2nd. So that's what we're factoring out. Now we need to see what's left. So 3 divided by 3 is 1. X to the 4th divided by x to the 2nd is x to the 2nd. -9 divided by 3 is -3. X to the 3rd over x to the 2nd is just x. And then 6 divided by 3 is 2. And 2x to the 2nd over x to the 2nd is gone. So that's what we're left with. Now, what we need to do is we need to see, can I factor that? Again, we don't want to just leave that trinomial in there. We want to see, can we factor that? So we'll put a 2 up here and a -3 there. We know that the only thing that multiplies to 2 is 2 and 1. And they could be negative, which actually does work. So this parenthesis, this trinomial factors to x minus 2, x minus 1. And what we got to remember is that we got to keep that 3x squared, that GCF that we originally factored out, it stays. So make sure you're checking your what's left behind after you factor. Make sure it can't be factored anymore. All right, number 11, we can see that the a value is 1. So these are the factor problems where we can just put our c value up top, our b value at the bottom. Need numbers that multiply to negative 15 that add to 2. Multiplying to a negative means my signs are opposite. 15 is 1 with 15, no 2, 3 with 5, and that's it. 3 and 5 look like they can get me to 2 if the 5 is positive and the 3 is negative. So we've got our numbers, x plus 5, x minus 3. In 12, a isn't 1. So we're going to look to see, is there a GCF? 2, 9, and 10. There is not. X's only in 2 spots, and Y's only in 2 spots. So no GCF, which means we're going to use, Xbox style. So remember, the top is going to be AC or 20. The bottom is B or 9. The inside of the box is going to be 2x squared. The bottom right corner will be 10y squared. We'll talk about that y squared in a second, how we fix that. So I need 2 numbers that multiply to 20 that add to 9. I'm thinking that's 4 and 5. Now normally we just put 4x. Today we're going to put 4xy because our middle term is xy. I'll factor over here first. I can factor it out of a 2 and a 4. I can factor out a 2. And then x in x, I can factor out an x, leaving me 1x up here. At the bottom now, I need 1x times what to get me to 5xy. I know that 1 times 5 gets me to 5. I already have the x. In order to get a y in there, I need to multiply by y. So I'm going to put a y there. I'm going to do the same thing in the upper right corner. 2 times 2 gets me to 4. I already have the x that I need here. But I do need to factor or bring in a y. Now you can see in the bottom right corner, 5 times 2 is supposed to be 10. We're good there. Y times y is y squared. We're good there. So we'll be x plus 2y times 2x plus 5y. Uh, 13, we see positive 36 here. I know that the square root of 36 is 6, and I know that 6 times 2 equals 12. So I actually see that this is a special case where I'm going to be y minus 6 squared, or y minus 6 times y minus 6. Again, without that recognition, we would be fine because we would put 36 at the top. Whoops. Put negative 12 at the bottom. 2 numbers that multiply to positive 36 that add to negative 12 is negative 6 and negative 6. And we would have our factor pairs that way. 14, hopefully recognize 49 is a square, so is y squared, so is 1, and it's subtraction. So this is the difference of squares. 49 is the result of 7 times 7. Y squared is the result of y times y, and 1 is the result of 1 times 1. And then we just put in our opposite signs. 7y plus 1, 7y minus 1. All right, 15. Again, you always want to look, is there a greatest common factor? 2, 16, and 32, those are all even numbers. So I'm going to factor out a 2. For the y's, I don't have a third y, so can't factor the y. Let's see what's left. Y squared plus 8y plus 16. Again, that 16 is kind of staring at me thinking, saying, hey, I'm a square. Square root of 16 is 4, and 4 times 2 is 8. Tells me I think we're going to be 2y plus 4 squared, or 2 times y plus 4 times y plus 4. All right, that should do it. If you can do that, you will be good on the test.